Hi, I'm Mr. Huber, and in this video we're going to talk about exercise 2. In a yeast culture, cell numbers are given by n is equal to 100 times e to the 1.03 t, where t is measured in hours after the cells are introduced to the culture. What is the initial number of cells? How many cells will be present after 6 hours? And how long will it take for the population to exceed 1,000? Okay, that's very easy. Well, first of all, I would really want you to write it like this. N, depending on t, or in terms of t, e to the 1.03 t. Well, A, what is the initial number of cells? Well, that couldn't be easier. N0. So 100 e to the 1.03 times 0. Well, that's 1, obviously, because e to the 0 is 1. So it's just 100. So the initial number of cells is 100. B, how many cells will be present after 6 hours? Very easy as well. After 6 hours, t is in hours, so 100 times e to the 1.03 times 6 is equal to, if you work it out, approximately 48,299 cells when rounded to whole cells, okay? Then C, that's slightly more difficult, but well, not too difficult. Well, NT, the number, depending on t, is greater than 1,000. That's the question. For which t is it greater to 1,000? Well, you just plug in what you know. Greater than 1,000. Now you divide both sides by 100. So e to the 1.03 t is greater than 10. Now, take the ln. Okay, well, ln e to the 1.03 t greater than ln 10. Now, well, this is the log to the base of e. So in this case, it's particularly simple because you can say e to the what is e to the 1.03 t? Well, obviously 1.03 t. You could also have said, well, 1.03 t times ln e. E to the what is e? Well, e to the 1. So you would have got 1.03 t as well, like this. Okay, but well, it just does undo the e to the power. Okay, so ln 10. Now you divide by 1.03, so t is greater than, that's approximately 2.24 hours. That's round about 2 hours and 14 minutes and some, okay? So 2.24 hours. There's one remark I would like to make here, because look, it's quite bizarre to write it up like this. 100 e to the 1.03 t. You could write it like this. 100 e to the 1.03. That's just a remark, okay? But oftentimes in science, you write things like this, like these, or like this, because for some other things that we could do with it in year 6, it's more practical, okay? So, but if you write it like this, everything should still be clear. So what's e to the 1.03? Well, e to the 1.03 is approximately 2.80. So when written in percent or in hundredths, it's 280 100ths, which is 280%. And what does that mean? So you could write it like this: 100, 2.80 to the t. It means that you start at 100% after, or at 100 cells, and after 1 hour you have 280 cells. So you go up to 280%, which means it's an increase, an hourly increase of 180%. So it's 280%. So you add 180% to what you had. Okay, I think that's quite important. 180% is the hourly increase. Keep this in mind. Well, as I said, in year 6 and year 7, we could do something to this function where this notation is way more practical. But well, at the moment, this notation would have been more practical because it's easier to imagine or understand what it does. It increases by 180% hourly. I hope it wasn't too difficult. See you in the next one.